A sequence is defined by this nth term, and we're asked to sum the first 39 terms. Well, let's work out a few of them. A1, let's be really careful here, is going to be minus 1 to the power of 1. Well, that's minus 1. Then minus 1 to the power of 0. That actually ends up being 1. So I'm minusing 1, and then I'm adding minus 1 to the power of 3, which ends up being minus 1 again. In fact, I end up subtracting 3 ones to give minus 3. So the first power was odd, the second power was even, and the third power was odd. When I go with A2, it's going to switch around. So now I've got minus 1 squared. Actually, that's a positive. Then I'm minusing minus 1 to to the power of 1. Actually, that's going to become a double negative. I'm going to get a plus 1. And then over here, I'm also going to get, I'm going to get an even number, so I'm going to be plusing 1 there. So I'm going to get 3. Now for A3, and I did mention this, like I was doing odd, even, odd, and it doesn't actually matter whether whether I'm using 1, 3, 5. The same thing's going to happen when you raise minus 1 to the power of it, because minus 1 to the power of 2n, where n is any integer, is going to be 1, and minus 1 to the power of 2n plus 1, or 2n minus 1, is going to equal minus 1 for such an integer, because minus 1 to an odd number is minus 1. So what I'm trying to say is they're just going to alternate. I mean, you can check if you want, but I'm hoping I've convinced you with the odd, even arguments. So that means when I sum them, I'm going to get minus 3 plus 3 plus minus 3 plus 3. And I can pair these up. There are 39 terms in total. So I'm going to get, well, there's going to be 38 terms that cancel out, essentially. There's going to be 19 pairs of minus 3, 3, minus 3, 3, and so on. So then my very last term, my 39th term, is going to be just minus 3. So all of these become 0, leaving me my final answer of minus 3. Well done.